Hi, welcome to Math with Kantoma. In today's class, we'll be talking about variation or proportion. Variation. So now in variation, we have like four types of variation. We have the direct variation, or direct proportion. So in direct variation, we say it's when two quantities varies directly to each other. As one increases, then the other quantity will also be increasing if they are in the same ratio. Meaning, if one quantity is increasing, let's say we have two quantities, y and x. Y is directly proportional to x, or y varies directly to x. Meaning, if y is increasing, then definitely the corresponding value of x will also be increasing. That is, they directly varies to each other. If one is decreasing, then the other quantity will also be decreasing because they varies directly to each other. So now this is the relation. By denoting the relation, we said this says y varies directly with x. So now if we remove the sign of proportionality, we'll have y will now be equal to kx, where k is the constant of the variation. So now I'll give you an instance, example. They said, example 1. Example 1 says, if y varies directly to x and y equals to 10 when x equals to 5, find the value of y when x is 15. So now this is a good example. They said y varies directly to x and y is 10 when x is 5. Find the value of y when x is 15. So now to do this, we relate the equation. They said y varies directly to x, meaning y is proportional to x. So now this is the symbol of the variation. If we remove the symbol of the variation, we have y is equal to kx. So now substituting the values of y and x, they said when y is 10, the corresponding value of x is 5. So if you substitute it here, we are going to find the constant of the variation in this first case. So now substituting the value of y to be 10 is equal to the constant of the variation is not given. So we are going to substitute for x, and x is equal to 5. So now if we simplify this, 10 is equal to 5k. We are looking for the constant. We divide both sides by 5 by 5. Let's go with this. 5 here is 1, 5 here is 2. So k is equal to 2, meaning the constant of the variation is equal to 2. So now if the question says we should write the equation that represents the situation, the equation that represents the situation is now going to be y equals to kx. Substitute the value of k to be 2, so y is equal to 2x. So now this is the equation that represents the situation. If at all they ask us, if at all the examiner asks us to find the equation that represents the situation, well, this is what we write. So now the question went further and says, find the value of y when x is 15. Meaning we are not giving y. We are giving x, we are giving k to be 2 also. And the value of x is 15, meaning we have to multiply x by 2. So therefore y is equal to 2 times 15 is 30. So the value of y is 30 when x is 15. So now if you look at these two values, are they increasing when the other value is increasing? In the first scenario, they say the value of y is 10 and x is 2. So now when it increases, as x increases to 15, the corresponding value of y is now equal to 30. So definitely they have a mutual relationship, meaning the corresponding value of y is increasing as the value of x is also increasing. So had it been the value of x is decreasing here, it's not up to 5, the face value, then we'll notice that the corresponding value of y will also be decreasing. It will not be up to this 10 because it will also decrease. So this is the relationship between the two variables x and y that are directly proportional to each other. So thank you for your time. In our next class, we'll discuss about the inverse variation, the joint variation, and also the mixed variation. So thank you for your time. If you have any question, you can drop it on the comment section. See you some other time.